How's it going? So I would like to use this video to do two things. One, go over some of the day 8 homework questions that you might have. And the other thing I'm going to do is I'm going to do the entire review packet on video. This is going to take a long time, and I'm not saying that you have to watch the whole thing, but I'm going to be honest with you, missing the days that I've missed this week, I feel bad, and I want to make sure that you guys get all the help that you could possibly need. I don't know what questions you're going to ask about the review, so I'm just going to do all of them. Yeah. All right, well, let's get started because it's going to take a while. So for day 8, I chose a few problems to go over. First, we have 1g. Suppose f of 4 is equal to 3 and f prime of 4 is 7. Let g of x equal x times f of x squared. Find g prime of 2. To be clear, you do not know in this problem what f is. You don't have a formula for it. All you know about f is these two things right here. So how are you supposed to do this problem? Well, you're trying to find the derivative of g at 2. And here's a formula for g. So we're going to take the derivative of that thing and plug in 2. So we want to take the derivative of g, fine. How do we do that? Well, this is a product of two functions, x times f of x squared. So we're going to need to use the product rule. So g prime of x is going to be given by what? Well, the derivative of the first function, derivative of x, is just 1, times the second function left alone. So that's just f of x squared. Plus, now we leave the first function alone, times the derivative of the second function. But I think most of us will start to feel a little unsure about what that derivative is, so I'm just going to write that second function and put a prime on it. Okay, so we can just focus on that. Right, so this is the product rule. Derivative of the first function times the second left alone plus derivative of the first function times the derivative of the second. And now in the next line, I'm going to actually think about what this derivative actually is. So the 1 here isn't doing anything. I can forget about it. Plus x times, and now we've got to think about this derivative. So right here, what you need to notice is that so it's a composition, right? It's a composition. You've got one function inside of another. The outside function is f of blank. And so the derivative of the outside function is actually just f prime of blank. What do we put inside the blank? Just the inside function x squared, but then we're not done. We also have to multiply by the derivative of the inside function, which is 2x. All right, and now I think this can be simplified a little bit. I think the second term, we should put this 2 in front. And then we've got an x here, and an x here, giving us an x squared, and then f prime of x squared. So I would say that's the derivative. Now we just need to evaluate all of this at 2. So that's f of 2 squared plus 2 times 2 squared times f prime of 2 squared. Well, obviously, 2 squared is 4, so this is f of 4, plus 2 times 4 times f prime of 4. And now finally we're able to use this information right here. F of 4 is 3, f prime of 4 is 7. So we make those replacements. F of 4 is 3 plus 2 times 4 times f prime of 4 is 7. And now you just simplify. That's 3 plus 2 times 4 is 8 times 7 is 56. So I think we get 59. So that is problem 1G. Problem 1H, we've got a limit. It's almost definitely a L'Hopital's rule problem. That's pretty much all the limits that we see. But we should make sure by plugging in the number and make sure that we get 0 over 0. If you do plug in pi, you get pi minus pi on top, and on the bottom, sine of 2 pi. Pi minus pi is definitely 0. Sine of 2 pi is also 0. 2 pi is just like a full rotation, so the y-coordinate is 0. Okay, so that's 0 over 0. That tells us that we are allowed to use L'Hopital's rule, so I'm going to take the derivative of the top and the bottom and try again. So we're going to look at the limit as x approaches pi of, okay, derivative of the top, I think is actually just 1, because pi is a constant. Its derivative is 0. Derivative of the bottom, you need to use the chain rule. The outside function is sine blank, so the derivative of sine blank is cosine blank. What goes on the inside? Just the original inside function, 2x. But then we have to multiply by the derivative of the inside function, which is 2. If we plug pi into this guy, we get 1 over cosine of 2 pi times 2. Cosine of 2 pi is 1, so this is 1 over 1 times 2, which is just a half, and that's the value of the limit. Problem 4f, we have, well, the next 3 problems are just derivatives. So this is a composition. 4f, this is a composition. The outside function is secant blank, so the derivative is going to be what? Well, the derivative of secant is secant times tangent. So the derivative of secant blank is secant blank times tangent blank. All right, what goes in the blank? Well, the inside function. As a matter of fact, we put that inside function in both the blanks. But then we're not done because we then have to multiply by the derivative of the inside function. Well, what's the derivative of 1 over x? Well, if you think about it, 1 over x is like x to the negative 1. So the derivative of x to the negative 1 would be negative 1 x to the negative 2. That's the derivative of 1 over x. That's basically it. You could maybe just simplify it. This negative 1 just makes the entire thing negative, and then, I don't know, I guess you could write it like this. This would certainly be one way of writing the answer. Probably not the only way. You could put the whole thing over a fraction bar, but whatever. Now we come to 4g, another derivative problem. This is, again, a composition. The outside function is cosecant blank. What's the derivative of cosecant blank? Well, it's negative cosecant blank cotangent blank. What goes inside the blanks? Well, the original inside function, square root of x. But then we're not done because we also have to multiply by the derivative of the inside function. The derivative of root x is, you can go through this whole thing. Root x is x to the 1/2. The 1/2 comes down. That's 1/2 x to the negative 1/2. You can write all that if you want. Although, honestly, you probably have the derivative of square root of x memorized at this point. I think I certainly, well, I do because I've been teaching the course for 8 million years, but I think a lot of people who are students in the course have also memorized it. So this last term, 1/2 x to the negative 1/2, that's just 1 over 2 square root of x. That's the derivative. I don't know, maybe you would put this guy in front. Maybe you'd put it over here, but whatever, that either way is fine. All right, last but not least, f of x equals root cosecant x. You should rewrite this as cosecant x all raised to the 1/2 first, and then we can see that the outside function is blank to the 1/2. So the derivative of the outside function is 1/2 blank to the negative 1/2. What goes on the inside? Well, the inside function. But then we're not done because we have to multiply by the derivative of the inside function. And what's the derivative of cosecant? Well, it's negative cosecant x times cotangent x. So there's the derivative. I think it can be simplified a little bit. You've kind of got two cosecants here. This is cosecant to the negative 1/2. This is cosecant to the 1. You can add the 1, I suppose, if you really want to. You don't need to, but and so those can be combined, right? Those can be combined. So I have 1/2. How many copies of cosecant do I have? So this is cosecant to the negative 1/2. Cosecant to the positive 1, you add those exponents. Negative 1/2 plus 1 is positive 1/2. So in fact, what you have is cosecant x to the positive 1/2. Also, this minus sign makes the entire expression negative, so I should put a negative in front, and then I've still got that cotangent over here. If you like, you could rewrite this as square root of cosecant. Same thing. Doesn't matter. Okay, so that's it for the homework review. Excuse me. My voice is going to get a lot rougher as this goes on, but we'll see how it goes. So moving on to the review. So this is the review. As far as the review, guys, what I'm going to say is that you should definitely do this whole packet, and like always, if you have time, do more. Maybe do the packet twice, or maybe go back and do old homeworks. The best way of doing well is to just do a ton of problems. Make sure that you have all the stuff that you need memorized. There's a lot of formulas in this unit. There's the product rule, there's the chain rule, there's the quotient rule, there's L'Hopital's rule, there's the derivatives of all 6 trig functions. So yes, that's a lot to memorize, but as I said before, we will actually ask you to just write down those formulas, and you'll get quite a lot of points just for doing that. So instead of being like, ugh, I have to memorize these formulas, you should be like, yay, I'm going to get a bunch of free points for memorizing these formulas, right? There's nothing easier than memorizing stuff. So, hopefully you know at this point in your math career how to memorize formulas. If you don't, basically you take a blank sheet of paper, you try to write down every single formula you're supposed to have memorized, then you check and make sure you've gotten them all and that you got them all right. And if you don't, then you put that piece of paper away, you start from scratch, and you try it again. And you keep repeating that until you can write down all the formulas you're supposed to know without any mistakes multiple times in a row, like 4 or 5 times in a row, and then do it again on the day of the test, right? Like maybe do that the day before, but then make sure that you do it again closer to the test so it's fresh in your mind. Anyway, let's do this review. Here we go. So let's have a look. So let me just do something really quick here. And okay, there we go. Good. So we are taking a bunch of derivatives. All right, so looking at this guy, okay, that looks like a chain rule problem to me. So the outside function is blank to the 5th. So I think I'm going to say take the derivative of the outside function. That's going to be 5 blank to the 4th. What goes on the inside? Just the original inside function, but then we need to multiply by the derivative of the inside function, which I believe is negative 12x squared. This can all be simplified a little bit. Stop that. Stop rearranging my equations. That can be simplified a little bit by writing, well, the negative 12 times the 5, I think will give you negative 60. And then we have 3 minus 4x cubed all raised to the 4th. And then I should put the x squared somewhere. I don't know. You could put it up front if you wanted. It doesn't really matter too much. Moving on to B, this looks like another chain rule problem. The outside function is cosine blank. So I'd say the derivative of the outside function is negative sine blank. What goes on the inside? Well, just 8 square root of x, the original inside function. But then we've got to multiply by the derivative of the inside function. Let's think about that. 8 root x is like 8x to the 1/2. The 1/2 would come down, give you a 4, and then subtracting 1, you'd get 4x to the negative 1/2. So that's the derivative of 8 root x. That's basically it. Maybe it can be simplified a little bit by, well, I don't know, not kind of, sort of. I don't know. I mean, I guess the 4 should be put up front. We kind of prefer to put coefficients at the beginning of the expression. The x to the negative 1/2, I guess that's like having a square root of x on the bottom of the fraction. So there we go. That looks good to me. By the way, I make a lot of mistakes when I'm typing equations. There's something about it that makes me screw up in a way that writing mathematics doesn't. I just tend to make more mistakes when I'm typing. So, I could make mistakes while I'm recording this video. Entirely possible, but hopefully it's kept to a minimum. All right, let's have a look at this one. Secant 3x times cosine 3x. Yeah, you could use the product rule on this. You could, but I actually know that's going to simplify to something really simple because, look, secant of 3x is the same thing as 1 over cosine 3x. Okay, which means that, in fact, this whole function is literally just equal to 1. And the derivative of 1 is 0. So that's it. If you use the product rule on this, like, you could eventually wind up here, but you'll probably have to, use a bunch of trig identities to get there anyway. All right, so, don't. This is another example of one of those problems where, just because you see a product doesn't mean you necessarily, ask yourself, can you simplify the function before you can take the derivative? Actually, in number 1, we tell you there are 2 problems that should be simplified before taking the derivative. Looks like that was the first one, so we'll be on the lookout for the other one. It's lurking in here somewhere. Letter D, the outside function is cotangent blank, so I would say that the derivative so the derivative of the outside function is, all right, what's the derivative of cotangent? I always forget, but I know the derivative of tangent. The derivative of tangent is secant squared. So the derivative of cotangent, it's going to be the cofunction, and it's going to be a minus sign. So it's negative cosecant squared blank. That's the derivative of cotangent blank. What goes inside the blank? Well, it's x squared plus x. But then we have to multiply by the derivative of the inside function, which you should put in parentheses because there's going to be 2 terms. It would be 2x plus 1, and that's the derivative. Very good. Now we come to E. Looks like this is another chain rule problem, so I think the outside function is secant blank. The derivative of secant blank is secant blank tangent blank. What goes on the inside of the blanks? Well, just the inside function. In fact, you put the inside function into both of the blanks, 4 over x squared into both of them, but then we also need to multiply by the derivative of the inside function. The inside function is like 4x to the negative 2. You take the derivative of that, it's going to give you negative 8x to the negative 3. So yeah, that's basically it. We just need to do some cleanup. So what is this going to be? I think it's, well, negative 8 over x to the third secant 4 over x squared tangent of 4 over x squared. I don't really think there's anything we can simplify about this besides that. Moving on to F, this is definitely a composition problem. Oh boy, this is going to be one of those double composition problems, right? You see the 4x to the third inside the sine function, inside the square root. So that's kind of a double composition. So let's go one thing at a time. I think maybe I would start by just rewriting this as sine of 4x to the third all raised to the 1/2, right? So just so it's super clear, the outside function, I would say, is blank to the 1/2. So the derivative of the outside function is 1/2 blank to the negative 1/2. Great. What goes inside the blank? Well, the inside function, which is sine of 4x to the third, but then we need to multiply by the derivative of the inside function. Cool. But the inside function itself is fairly complicated, so I'm just going to postpone the differentiation of that guy until the next line, because I'm a little bit worried about trying to do 2 chain rules in the same line. All right, and in the next line, I'll actually compute. Oh, I forgot a prime on here, my bad. In the next line, I'm going to compute what y prime actually is here. So 1/2 sine 4x to the third. I'm just copying all of this stuff. But then, what is going on here? What in the world is going on there? All right, something weird is happening with that equation there. Sometimes there's weird stuff going on with the equation editor, but I usually can make it work. There we go. Okay, so I just recopied the first term. Now I need to find the derivative of this guy here. As I said, that guy is itself a composition. The outside function is sine blank, so we take the derivative of the outside function, that's cosine blank. What goes here? Just 4x to the third, but then we need to multiply by the derivative of the inside function, which is 12x squared. Oh boy, I'm running onto the other line. Let's give myself some more room. There we go, so there is our derivative. It could be simplified a little bit. The 12 can multiply with the 1/2 to give you a 6. And maybe this guy, if you don't like negative exponents, then you could move this stuff to the bottom of a fraction, but I think you can probably do that on your own. Let's move on to G. Y equals, okay, this looks like a product to me. And by the way, just remember, anytime you see, the secant 2x stuff, like this means x squared times secant of 2x, right? Like the 2x is on the inside of the function. So there's a product rule problem. So we're going to take the derivative using the product rule, so it's going to be what? It's going to be the derivative of the first function times the second function left alone, plus the first function left alone times the derivative of the second function. That's a little bit complicated. That's why I'm postponing the differentiation, because I sort of recognize this is going to be a chain rule thing, so I don't want to try and do all that at once. All right, so what's next? We need to actually compute the derivatives that I didn't in the first line. So derivative of x squared, that's 2x, so 2x times secant 2x plus x squared. Okay, now what is the derivative of this guy? Well, the outside function is secant blank. The derivative of secant blank is secant blank tangent blank. What goes here? 2x on both of them, but then we're not done because we also have to multiply by the derivative of the inside function, which is 2. And I'll bet that a lot of people will miss this too, because they try to do everything in one line and they forget about the chain rule that needs to be applied to this guy. Very sneaky, that too. This can be cleaned up a little bit. Maybe you'd put this 2 like over here, and I guess maybe you could pull out a common factor or something. But that's not super important. I think that you guys can probably do that on your own. let's move on to this one. Okay, once again, you've got these shenanigans where the tangent function, you know, like I want to have some parentheses here, right? So just to be clear, what in the world? So just to be clear, this means, oh boy, what is going on here? Okay, tell you what, I think that I'm going to switch to a different Word document because, in case you're wondering what's happening here, the reason that the equation editor is being so weird here is that this is a very old file, and Word is struggling to interpret the old Word file in my somewhat newer version of Microsoft Word. That's what's causing equation editor to be weird. So what I'm going to do is I'm just going to do my work in a separate Word file as we go through the problem set, and I know that that will not cause any issues. So let's work on this one. So we're trying to find the derivative. This is h now. Trying to find the derivative of this guy. The first thing I'd say is, like I said, this really means 2 square root of x times the tangent of square root of x. I really like to have parentheses on my trig functions, so I would first rewrite it that way. Now, what is this? Well, we need to find the derivative. I would say that this is a product rule problem. This is the first function, the 2 root x, and then the tangent root x is the second one. These derivatives are going to be complicated, so I'm not actually going to compute them right away. I'm just going to prime them. So derivative of the first function times the second function left alone plus the first function left alone times the derivative of the second function. So let's put a prime there. Okay, and now I'll actually compute, what are these derivatives? So this gives me, let's see, y prime. So derivative of 2 root x, that's like 2x to the 1/2. The 1/2 comes down, kills the 2, and I think you're just left with x to the negative 1/2. Okay, so times tangent square root of x, very good, plus 2 square root of x, and now I've got to compute the derivative of this guy, but this guy is a composition, so I need to use the chain rule. Outside function is tangent blank. The derivative of tangent blank is secant squared blank. What goes here? Well, just the original inside function times the derivative of the inside function. That's the derivative of root x. I know from experience that that's just 1 over 2 root x, but, And, yeah, I mean, I don't know. I guess that we could kind of clean this up a little bit because, I don't know, if you wanted, you could put this x to the negative 1/2 into the denominator of this term, and then this term and this term would have, almost the same denominator. Or actually, no, I think they would, because if you look, this 2 right here and this 2 right here, they're actually going to cancel. So let's go boop and boop. And then if you make this x to the negative 1/2, if you put that into the denominator, both of these guys are going to have a square root of x in the denominator. I assume the instructions tell you to put things over common denominators, right? Probably. Blah, blah, blah. Simplify coefficients and factor out the GCF. No, okay. It doesn't say put things under common denominators, so I guess there's not really any reason to do so. So in that case, maybe, I don't know, I mean, you could write the first term as tangent square root of x over square root of x, and then this second term, actually, this guy cancels with this guy, so if you don't care about common denominators, you might as well cancel those and just be left with this. This is a perfectly good answer to me. Like there's not really any reason to put these over common denominators or anything. So okay, so very good. Moving on. We are moving on to, that was problem G. Now we're moving on to, oh no, that was problem H. So now we're moving on to I. You're in trouble when the letters go up to I in a math problem. It's like, oh, you've got 2 exercises. But they go up to like Q. So let's do this one. So our function is y equals square root of x times square root of x plus 6. They put a dot in between these two things. There's no need to do that. The multiplication is implied, but anyway, okay, you could use the product rule on this. You could, but I think that it's actually probably easier to just rewrite this, because this is really just like, well, I mean, I don't even need to convert to fractional exponents to see what's going on here. If you distribute this root x, it cleans up very nicely, because root x times root x is just x, and then plus root x times 6 is just 6 root x. And that is a lot easier to find the derivative of. Now I don't have to use the product rule. So y prime, that's going to be 1 plus, all right, what's the derivative of 6 root x? That's like 6x to the 1/2. The 1/2 comes down, makes the 6 into a 3, and then you have a negative 1/2. So that's like y prime equals 1 plus 3 over square root of x. By the way, one quick thing, guys. A lot of people on the last test, the last unit test, you had to do a lot of rewriting before you took the derivative. A lot of people rewrote the function and then just totally forgot to take the derivative, even though they probably knew how. Don't do that on this test. Make sure you actually at some point take the derivative, okay? Oh god, it's one of these. Okay, yeah, let's find the derivative of this monster. These things are always a pain. So, yeah, let's just get through it. So this is number 3. All right, so I'm just going to copy it over here. So this is y equals quantity x plus 3 to the 4th times 2x plus 1 to the 5th. We're going to find the derivative and simplify completely fine. So first of all, this is a product. So product rule says take the derivative of the first thing and leave the second thing alone. You'll notice I'm not actually doing the derivatives in this line because the derivatives themselves are pretty complicated. Now I leave the first function alone and I take the derivative of the second term. So put a prime on that. Now let's actually compute those derivatives. Okay, derivative of this guy here, it's a chain rule. The outside function is blank to the 4th, so I get 4 blank to the 3rd. X plus 3 goes on the inside. Then I need to multiply by the derivative of the inside function, which is just 1. So I guess it's not really doing anything, but whatever. And then the 2x plus 1 to the 5th is just left there, plus now I'm just recopying the x plus 3 to the 4th, and now I need to find the derivative of this guy. That's a composition. Outside function is blank to the 5th, so the derivative of that is 5 blank to the 4th. What goes inside here? 2x plus 1, but I'm still not done because I need to multiply by the derivative of the inside function, which is 2. So maybe I can clean this up a little bit. I kind of don't like having multiple coefficients here and here floating around inside the same function, so it's a bit silly to rewrite this entire expression just for that. But oh, and this 1 isn't doing anything either, and let me just sort of forget about that. Plus, and then the 5 times the 2 gives you 10, and I'll put the 10 in front. Yeah, and I think that's all the simplification that I'll do right now. And now, of course, it says simplify completely. I assume that means it wants us to pull out common factors. We probably should do that. So let's see. Start with the coefficients 4 and 10. I think the only thing I can pull out is 2, so I'll pull out 2. The largest number of copies of x plus 3 that I can pull out is 3, right? This term only has 3 copies of x plus 3 to give. As far as 2x plus 1, the most I can pull out is 4 because this term only has 4 copies of 2x plus 1 to give. And now I set a brackets and I write whatever's left. So this guy here, this is the greatest common factor, and now I'm going to write whatever's left over inside the brackets. So what's left over in this term? I pulled 2 out of 4. That leaves me with 2. I removed all 3 copies of x plus 3 to the 3rd, but I only removed 4 of the 5 copies of 2x plus 1, so I've still got a copy of 2x plus 1 left over. Plus, now I ask what's left over in this term. Well, I pulled 2 out of 10. That leaves me with a 5. I removed 3 of the 4 copies of x plus 3, so that still leaves me with a copy of x plus 3. And I removed all 4 copies of 2x plus 1, so there are none of those left over. And now all that I need to do is distribute and collect like terms inside the brackets. Distributing the 2 gives me 4x plus 2. Distributing the 5 gives me 5x plus 15. And now if I collect like terms, I will be all set. So that's 9x plus 17, right? Okay, that looks simplified. Moving on, we are now moving on to this one, apparently. Find the derivative of this function at pi squared. Okay, so we're looking at number 4. So we're going to take the derivative. So what is my function? My function is 6 times tangent. And again, I like to use parentheses, tangent of square root of x. and we wanna find f prime of pi squared. Okay, so first let's find the derivative. This is a chain rule. Outside function is 6 tangent blank. So the derivative of 6 tangent blank is 6 secant squared blank. What goes inside here? Well, square root of x. By the way, this square here and this root x, they do not cancel. Like, if you think they do, then you've made a mistake. They do not cancel, okay? Let's see. Okay, but we still need to multiply by the derivative of the inside function, right? Inside function is root x. Derivative of root x is 1 over 2 root x, so there's our derivative, although I think it can be cleaned up a little bit. This, like, over 2 will just change this guy into a 3, so I think maybe what we've got ultimately is 3 secant squared of the square root of x all over square root of x. Okay, fine. And so now I need to evaluate this at pi squared. So f prime of pi squared will be, I've got a feeling a lot of people are going to have trouble with this one just because it involves some nasty trig values. So square root of pi squared all over square root of pi squared. Well, okay, so let's see. So this is 3 secant squared of, what's the square root of pi squared? Well, it's just pi, right? And then again, square root of pi squared is just pi. Okay, fine. So now how do you evaluate this? You know, remember what the square here means. This really means 3 times secant of pi, like all squared. So you just need to figure out what secant of pi is and then square that bad boy. So what is the secant of pi? I have no idea. I just think about the fact that secant is the reciprocal of cosine. So this is really cosine of 1 over, it's 1 over cosine pi all squared. That's what secant pi is, right? Secant pi is 1 over cosine pi. So, okay, I can do that. So what's cosine pi? I think it's -1. So this is 3 times 1 over -1 all squared. And yeah, okay, 1 over -1 is -1, so that's 3 times -1 squared over pi. That -1 gets turned into a +1 by the square, so in fact it's just 3 out of pi, assuming I didn't screw up anywhere. Good, that brings us to number 5. So, yeah, what's number 5 about? Find the derivative of each quotient below, simplify completely. There's only one I'd use the quotient rule for. Yeah, okay, so, okay, yeah, you could use the quotient rule on this if you were a sucker, but you shouldn't. You should instead just split the fraction. So splitting the fraction, that's 16x to the 8th over 4x squared plus 20x to the 3rd over 4x squared. So yeah, that would be, that simplifies to 4x to the 6th plus 5x, and all right, that's much easier to find the derivative. Like I said before, don't forget to take the derivative, don't just simplify. Okay, so that's 24x to the 5th plus 5, and that looks like the answer, I think. I don't know, I don't have the answers in front of me. Oh good, there's 2 number A's, or 2 letter A's, perfect. Well, whatever. Okay, presumably this is supposed to say B. This one here, I think this one you actually need the quotient rule for. Don't think that there's any kind, please don't think that the x squared here will like cancel with some of the x's down here. That doesn't work. These x's are locked inside the sine function and really can't interact with anything else. So this is 5, I'm gonna call this, I mean, I don't know, I'm gonna call it 5b, even though it says a, it should say b. So this is, so our function is sine of x squared over 4x to the 4th. Okay, fine. So, yeah, so we need the quotient rule. So quotient rule says, yeah, and the thing is, do you notice that the numerator is itself a composition? So that means that this derivative is going to get pretty complicated, so I'm not actually going to take any derivatives in this one. I'm just going to set the quotient rule up and postpone the differentiation. So quotient rule says, take the derivative of the top. Okay, I'm just going to write the top and then put it in brackets and write prime. Okay, times the bottom left alone, so times 4x to the 4th, minus the top left alone, so that's sine x squared, times the derivative of the bottom, and I'll just write 4x to the 4th, prime, all over the bottom squared. If you square the denominator, you got to square everything here, including this coefficient of 4 that's in front, so that's actually going to give you 16x to the 8th. Make sure you're keeping your exponent rules straight on that one. All right, so next we got to actually compute all these derivatives. So sine of x squared prime. All right, this is a chain rule thing. Outside function is sine blank. Derivative of sine blank is cosine blank. What goes on the inside? X squared. But then you got to multiply by the derivative of the inside function, which is 2x. And then we've still got, of course, that 4x to the 4th that was sitting right here. Very good. Then minus sine of x squared. I'm just copying. And now we're going to take the derivative of 4x to the 4th. Well, that would be, of course, 16x to the 3rd all over 16x to the 8th. Can this be simplified? Yeah, probably. I should probably do it, even though I don't feel like it. So let me see. This stuff here, that's really 8x to the 5th. Let me put that in front and then write the cosine x squared. Minus, not much to do in this one. I don't know. I guess you could put the 16x to the 3rd first. Sort of by convention, people usually put polynomial stuff like this first, but you don't have to. All over 16x to the 8th. Guys, please don't think that this 16 here cancels with this one. It does not. Okay, you need to factor the numerator, pull out the common factors in the numerator before you even think about canceling stuff. So in the numerator, let's see, there's a coefficient, there's a common factor of 8 that I can remove from both terms, right? 8 goes into itself and 16. I can also pull out, I think, x to the 3rd from both of these guys. So that's x to the 3rd and then quantity. Yeah, and that's all that I can pull out, right? So 8x to the 3rd is the GCF. What's left over in this term? I think just x squared cosine of x squared is all that's left in that term. And then in this term, we pulled 8 out of 16. That leaves us with a 2. And we removed all the copies of x, right? So there are no copies of x left over there, but you still got the sine of x squared all over 16x to the 8th. And now we can do some cancellation, right? Because this 8 here is gonna sort of, the 8 and the 16 is really just like 8 over 16. It's like 8/16. So that's just like 1/2. Okay. And also this x to the 3rd is going to cancel with 3 copies of the x to the 8th down there. So what is left? Well, this entire guy here, sorry, stop highlighting so much, stupid. This guy right there is the common factor, and that entire thing is just going to be canceled, right? So all that's left in the numerator is the terms in parentheses here. So that's x squared cosine of x squared minus sine of x, 2 sine of x squared. In the denominator, what's left after cancellation? I think it's 2x to the 5th. Okay, great. Moving on. That was 5b. God, what a doozy, right? That was a pain. Why are you not letting me zoom in? Let me zoom in. Okay. So moving on, we've got this one. Yikes, that looks like a weird looking function. What is going on there? So this is 5c. Let's look at 5c. Our function is originally written in a very stupid fashion. It's y equals 1 over cosine. They write it this way. They don't use any parentheses. I don't know why. I would really write this as cosine 3rd of 5x. But of course, even that sort of needs to be rewritten. Like to be clear, what is that? That's like, anytime you see a power of a trig function, you should always rewrite it. So what that really means is cosine of 5x all to the 3rd. Now, even writing it this way, you might think that you need to use the quotient rule, but you really don't. You can just rewrite this with a single negative exponent. Like you can rewrite this as cosine of 5x to the -3, and now it's just kind of a chain rule problem. Although it's a double chain rule problem, so it's still kind of annoying, but better than it was. So, okay, double chain rule, right? Because you got 5x inside of cosine, inside of the blank to the -3. So, okay, derivative of the outside function. The outside function is blank to the -3, so the derivative of that is -3 blank to the -4. What goes inside here? Well, just cosine 5x. Then times the derivative of the inside function. But the inside function itself is quite complicated, so I'm going to postpone that differentiation, right? There's the inside function. I'm just going to put it in brackets and write prime. Figure it out in the next line. So that's -3. I'm just going to copy this line for right now. I'm not going to worry about simplifying it yet. And what is the derivative of this guy? So, well, it's a composition. Outside function is cosine blank. Inside function is 5x. So the derivative of cosine blank is negative sine blank. What goes inside here? 5x times the derivative of the inside function, which is 5. Okay, so I think that's the derivative, but it needs to be cleaned up quite a lot. First of all, this minus sign will cancel with that minus sign, which means that our final answer is going to be positive. We've got two coefficients. We've got a 3 and we've got a 5. That's going to be 15. So it's positive 15 what? Well, this thing to the -4 is going to create a fraction. You're going to have, cosine of 5x all to the +4 in the denominator. But this sine of 5x is going to be left in the numerator, and I would say that is a perfectly good answer. So that is 5C. Moving on, we now have 5D. Okay, yeah. So, yeah, this one I would also definitely would not do the quotient rule, because you're much better off simply splitting the fraction, that's square root of x over square root of x minus 1 over square root of x, which is really just 1 minus x to the -1/2, right? So, okay, so now we can take the derivative of that. Derivative of 1 is 0. What's the derivative of this guy? Well, the -1/2 comes down. It already has a minus sign, so it actually becomes positive 1/2 x to the -3/4, which is like 1 over 2x to the +3/4, which, if you like, is like 1 over 2 times the 4th root of x to the 3rd. Okay, yeah, so there's my answer. Very good. So that is 5D. Moving on to number 7. Okay, very good. So we've got this problem here. Suppose that g of 3 is 5, g prime of 3 is 7. Let h of x equal 1 over g of x. Write the equation of the tangent line to h at x equals 3. Okay, so tangent line. So first of all, anytime you want a tangent line, you want to think y minus y1 equals m times x minus x1. You need two things, the point on the line and the slope. For the point, well, since we're trying to find the equation of the tangent line at 3, obviously the x-coordinate is going to be 3. For the y-coordinate, well, since we're trying to write the equation of the tangent line to h, we want to be plugging x equals 3 into h, right? We want to evaluate h at 3. So the point is 3 comma h of 3, whatever that is. You can figure out what h of 3 is, though, right? Because h of x is 1 over g of x. So that's going to be, so h of 3 would be 1 over g of 3. G of 3 is 5. So I think that's just 1 over 5, right? So there's the point on the line. Now, for the slope of your line, you need to be plugging 3 into the derivative of h. So we need to know h prime of 3, which of course means that we need to know h prime in general. H prime of x is going to be what? Well, actually, let's back up a second. So I need to find the derivative of this function here. I would rewrite this first. I wouldn't use the quotient rule on this. Like, you could, I don't know, but it's much better to just rewrite it. So before I take the derivative, I would say h is really g of x all raised to the -1, right? That's easier to work with. That's just kind of a chain rule thing. So h prime of x is going to be, okay, outside function is blank to the -1, so I get -1 blank to the -2. What goes here? G of x. Then we have to multiply by the derivative of the inside function. Well, the inside function is g, so the derivative of that is just g prime. So yeah, and if you want to rewrite this, sort of not using negative exponents, you could say this is really negative g prime of x over g of x squared, right? I think is what that really means. And so if we want to evaluate this whole thing at 3, then I would say h prime of 3 is, okay, it's negative g prime of 3 over quantity g of 3 squared. Well, g prime of 3 is 7. That's what we're told. So this is actually just negative 7. And then g of 3 is just 5. So that's 5 squared. So that's negative 7 over 25. I feel like I did this problem before, and I don't remember the slope being negative. I thought it was positive 7 over 25. Let me just really quickly check my answers. Oh no, negative 7 over 25. It's good. Okay, never mind. I'm just imagining things. Okay, so now we're ready to write down the equation of the tangent line. So equation of the tangent line is, so y minus y1, we said y1 is 1/5, equals m, the slope, we just found that's negative 7 or 25, times x minus x1, that's 3. So there's the equation of the tangent line. Lovely. Great, so that's part A. Part B says approximate h of 3.1. The way to do linear approximation is you always just write down the equation of the tangent line at some appropriate point. We've already got the equation of the tangent line at 3, which is very close to 3.1, so if you want to approximate h of 3.1, just plug 3.1 into this guy right here. So approximating h of 3.1, we would just plug 3.1 into the tangent line here. So that would be y minus 1/5 equals negative 7 over 25 times 3.1 minus 3. And now you just got to solve for y, and that's your approximation. So that's y minus 1/5 equals negative 7 over 25 times 0.1. Yeah, if you want to sort of write this without decimals and stuff and like no calculator, you know, this 0.1 is really like a 1/10. So this is like this fraction times 1/10. So that would give you negative 7 over 250. And so therefore finally y is equal to negative 7 over 250 plus 1/5. Common denominators, that's like negative 7 over 250 plus, I think 1/5 is like 50 over 250. So that gives me 43 over 250. I swear that this wasn't negative when I did it before. I've got to check my answer here again, or maybe I'm just losing my mind, but I really feel... Oh, I told you, look at that, see? Positive 7, I made a mistake in my original answer. In the version of the worksheet I uploaded, it'll be fixed. But yeah, you see that? I had a feeling. I thought, yeah. Okay, so that's supposed to be negative, and so that actually gives you, okay, yeah, 43. Good. Okay, cool. All right, so that is number 7. So let's see. Where are we now? Okay, now we're moving on to number 8. Evaluate the following limits. These are probably all L'Hopital rule problems. Although this guy right here, I can tell you right now, is actually one of those derivative in disguise problems. You guys remember that? Limit as h goes to 0 should be a dead giveaway. I think you can theoretically use L'Hopital on this, but like it's kind of stupid to do so. This is just giving you the derivative of cosecant at pi over 6. So just find the derivative of cosecant at pi over 6. But anyway, the rest of them are probably L'Hopital. So let's see, this one here, so what is this? 8a. So 8a, so let's have a look. So we're looking at this limit here. Probably it's L'Hopital, but the first thing we need to do is plug the number in. So that's 2 to the third minus 4 times 2 all over 2 to the third minus 6. That's 8 minus 8 over 8 minus 6, which, oh, that's 0 over 2, which is just 0. And that's the answer. That's the answer. It's just 0. You're not allowed to use L'Hopital's rule here. Okay, you can only use L'Hopital's rule if you get 0 over 0, and we did not get that. We got 0 over 2, which is just 0. Remember, if you plug the number into a limit and you get like a regular number, then that's the limit. And that's what's happened here. There's no need to use any fancy L'Hopital's rule stuff. So be on the lookout for that, right? When you're using L'Hopital, and if you try to use L'Hopital on this thing, I think you'll get a different number. Like, I think you'll just straight up get the wrong answer there. So be careful. All right. So B. Okay. So what's going on here? Once again, we should plug the number in, right? So 8B. Plug the number in. What is that going to give us? If I plug 4 in, that's 4 to the third, which is 64, plus 4 squared, which is 16, minus 80, over square root of 4, which is 2 minus 2. Yeah, that's 0 over 0, right? That's 0 over 0, which means that we are allowed to use L'Hopital's rule, which means we can take the derivative of the top and bottom and try again. Taking the derivative of the top, that's 3x squared plus 2x. Derivative of the bottom, derivative of root x is 1 over 2 root x. Okay. And so now if I plug in 4, I get 3 times 4 squared. 4 squared 16, so 3 times 16 is 48. Plus, plug 4 into this guy right here. That's just going to give you 8. Cool. Over 1 over 2 times the square root of 4. So that's like 56 over 1 over 2 times. All right. Square root of 4 is 2, so 2 times, that's just 4. So 56 over 1/4, keep it, change it, flip it. You know, if you're not sure what to do about this, you know, make both the top and the bottom a fraction. 56 can be thought of as 56 over 1, right? So that's really just going to be like 56 times 4 over 1, which is just 56 times 4, which is 56 times 4 is 224. Okay, cool. Great. So that is B. Moving on to C. Oh boy. Okay, so this, all right, so let's have a look. So 8C, we should plug the number in and make sure that we actually get like 0 over 0 or something, right? So sine of 0 is 0, squared is still 0, cool. The denominator, plugging in 0, you're gonna get 0 minus 3 times, okay, cosine 0 is 1. So that's minus 3 plus 3. Yeah, so you do get 0 over 0, which means we can use L'Hopital's rule. So I'm going to take the derivative of the top and the bottom. The top is a chain rule problem. It's a composition. So the outside function is blank squared. So I get 2 blank to the 1. That's the derivative of the outside function. Put the inside function right there. But then we got to multiply by the derivative of the inside function, which is cosine x. Great. Derivative of the bottom is 2x. Let's think. Derivative of cosine is negative sine. This term's already negative, so it's actually going to become positive when I take the derivative, and then derivative of 3 is 0. So, okay, so there's the derivative. Now, let's try plugging in 0 again. So I get, okay, the top is 0 because sine of 0 is going to be 0. And then, and the bottom is also 0. Oh, God. Okay, fine. So you get 0 over 0, which means we have to do L'Hopital again. So let's take the derivative of the top and the bottom again. The numerator is a product, so I need to use the product rule. I would view this as like, as the whole first function is just 2 sine x. You see what I mean? Just view the whole first function as 2 sine x, and the second function is cosine x. So, all right, derivative of 2 sine x is 2 cosine x, and then I leave the second function alone. Plus, now I leave the 2 sine x alone, and I take the derivative of the cosine, which gives you negative sine. Okay, fine. All over, so that's the product rule on the numerator. In the denominator, the derivative is pretty easy. That's just 2 plus 3 cosine x. Okay, the numerator probably can be cleaned up a little bit. 2 cosine x times cosine x, that's just 2 cosine squared x. And then because of this minus sign, the whole second term is actually negative. So we're going to have minus 2 sine squared x all over 2 plus 3 cosine x. Now let's try plugging in 0 again. I don't think you get 0 over 0 this time. Plugging in 0 here, cosine of 0 is 1, squared is still 1, times 2 is just 2. Plug 0 into this, you'll get 0. Plug 0 into all this stuff, I think you'll just get 5. So 2/5. There we go. That is problem number C. Marvelous. That was annoying. This one I sort of already talked about. You know, I guess you could do L'Hopital's rule here. The variable's h, but, you know, the derivative otherwise is the same. You got to be careful because, you know, this first term here is actually a composition, right? And then this second term here, when you're taking the derivative, this is a constant. Like cosecant of pi over 6 is just a constant, so its derivative would be 0. So you could do L'Hopital on this, like, you know, you could do it, but you're better off just recognizing that this is actually just a derivative in disguise. That whole thing, what is this? What are we on? This is 8. This is 8D. So 8D, like, you should just recognize that that's a derivative in disguise. That's actually just giving you the derivative of cosecant x at pi over 6. So take the derivative of cosecant x, plug in pi over 6. So what will that be? The derivative of cosecant is negative cosecant cotangent, right? And then I just need to plug pi over 6 into that. Oh boy, what a joyful experience this is. So now I have to figure out what all of this is. So negative, what is cosecant pi over 6? I have no idea, but I do know that cosecant is the flip of sine. So that's 1 over sine of pi over 6. And then times, what is cotangent of pi over 6? I don't know, but it's 1 over tangent of pi over 6. It's just the reciprocal of tangent. So now I just got to compute these two things. So this is negative 1 over sine of pi over 6 is a half. So it's negative 1 over a half times tangent pi over 6. That's root 3 over 3. You probably don't have that memorized. You can, you know, you can derive it if you want because it's just sine of pi over 6 over cosine of pi over 6. So now you got to do some keep it, change it, flip it stuff. Like the 1 over the fraction just flips the fraction upside down. So 1 over 1/2 is just going to be 2. And then 1 over 3 over root 3 is just, 1 over root 3 over 3 is just going to be 3 over root 3. And so I guess that's, negative 6 over root 3. And now if I rationalize that denominator, I get negative 6 root 3 over 3. And then you can divide the 3 into the negative 6. And then that gives you negative 2 root 3. Yikes. Okay. Well, that was kind of troublesome. But anyway. All right, so moving on. Number 10, use calculus to find the 3 coordinates where y equals blah, blah, blah has a horizontal tangent. I like that it says use calculus. Like, what else would you use, right? I mean, this is a calculus class. Anyway, like you could sort of preface every problem with the phrase use calculus. Anyway, yeah, so we want to know where this thing has a horizontal tangent line. That just means you want to set the derivative equal to 0 and solve. So I need to start by finding the derivative. Well, I think you need the quotient rule for this. I don't think that there's any way around it. So let's do the quotient rule. So I have the derivative of the top is 3x squared times the bottom left alone minus the top left alone times the derivative of the bottom, which is just 2x. All over the bottom squared, that's x squared minus 1, quantity squared. Let me clean it up a little bit. So that's going to be distributing the 3x squared here. That's going to be 3x to the 4th minus 3x squared. And then this term here is really just like minus 2x to the 4th. Right? So minus 2x to the 4th. And don't expand the denominator. That would be a mistake. Just leave it. And then I think that there's some like terms like this guy here and this guy here can be combined. So that's x squared minus, so I'm not changing the denominator. But in the numerator, 3x to the 4th minus 2x to the 4th, that's just x to the 4th minus 3x squared. So that is the derivative simplified. Now we're trying to figure out where is the tangent line horizontal. That means set this derivative equal to 0 and solve. Anytime you have variables in denominators, you should just clear denominators. So if you just multiply both sides of this equation by this denominator, you'll just clear the denominators and you'll just be left with the numerator equals 0, right? because 0 times anything is still 0. So you'll find that x to the fourth minus 3x. Wait, why am I making a fraction bar? The x to the fourth minus 3x squared is equal to 0. That can be solved by factoring. Pull out the common factor of x squared. That gives you this. So setting this factor equal to 0 will give you x equals 0. If you set this factor equal to 0, you'll get x is equal to plus or minus square root of 3. Don't be forgetting your plus or minuses, guys. Okay, so there. Does that match up with the graph? I mean, am I crazy? Yeah, no, it's looking pretty good, right? That, like, square root of 3 is probably around here. Square root of 3 is like 1.73. Yeah, looks about right. Okay, cool. Moving on. Okay, I think we're most of the way through here. All right, so now we're looking at number 11. So, go away. Number 11. Consider y equals f of x to the right. Okay, I'm considering. For each variation below, write an expression for the derivative in terms of f and f prime. Check your answers and then evaluate everything at 2. I'm just gonna find the derivative and then I'm gonna evaluate it at 2. I'm not gonna do it the Henry Ford way. So 11a. Let's see. Okay, so y prime. So first of all, 11a, like you should say to yourself that really means f of x all to the third, right? Like that's what that function really means. And so it's a chain rule problem. The outside function is blank to the third, so you get 3 blank squared. F of x goes on the inside, but then times f prime of x, right? Okay, so now you just need to evaluate everything at 2. So what would that give you? That would give you 3 times, well, if you evaluate f at 2, what is f of 2? We can tell from the graph, right? F of 2 is 4, so that's going to be 4 squared times f prime evaluated at 2. So what's f prime of 2? Well, this is a graph of f. F prime at 2 is just the slope at 2. Right? So what's the slope at 2? Well, this whole thing's a line. The slope is very clearly just 2. So f prime of 2 is 2. So that's 3 times 4 squared. That's 3 times 16, which is 48. 2 times 48 is 96, I think, right? I mean, if that's not exactly right, it's close enough. I shouldn't say that. 11b. So again, this is a chain rule thing. I would rewrite this as f of x to the 1/2. So the derivative is going to be y prime equals 1/2 blank to the negative 1/2. F of x goes on the inside, but then times the derivative of the inside function, which is f prime. All right, cool. So now you just got to evaluate all of that at 2. I should really write this down. Like, as a matter, like, I already went through what f of 2 and what, well, let me just write it down up here, right? Like, what did I say? So evaluating this whole thing at 2. F of 2 is 4 and f prime of 2 is 2. So let's just have that information there so I don't have to keep looking at the diagram every single time. So evaluating everything at 2, you get 1/2. F of 2 is 4, so that's 4 to the negative 1/2 times f prime of 2, that's 2. Yeah, if you simplify, you'll get the answer, okay? I mean, I think you guys can do that on your own. Okay, let's move on to C. So 11C would be, I need to use the product rule on this guy, right? So the derivative is going to be 1 times f of x plus x times f prime of x. That's the product rule, right? And so evaluating everything at 2 would give you 1 times f of 2, which is 4, plus x, which is 2, times f prime of x, which is, f prime of 2, which is also 2. So that's 4 plus, I think that gives you 8. 11d is we've got y equals f of x to the third. So the derivative, you're definitely going to need to use the chain rule. that's, so the outside function is f of blank. So the derivative of the outside function is f prime of blank. X to the third goes there, times the derivative of the inside function, which is 3x squared. Yeah, and then plug in 2, and you'll have your answer, right? I think, maybe I'll do that. All right, so that's going to be f prime of, plugging in 2, that's going to be 2 to the third, which is 8 times 3 times 2 squared. What is f prime of 8? That's the slope at 8. What's the slope at 8? Well, I don't know. I mean, I'm assuming that this line just keeps going, right? Which means that, like, the slope at 8 is the same as the slope over here because it's just the same line the entire time. And this slope here is -3, so I think that that's just -3. So it's -3 times 2 squared, whatever number that is. That's your answer. So 11e f of x. Okay, this is kind of fun. I like this question. So 11e, that's a composition, but both the inside and outside functions are f. So the outside function is f of blank, right? So the derivative of the outside function is f prime of blank. What goes on the inside? Well, the inside function, but the inside function is just f of x, right? All right, times the derivative of the inside function, which is f prime of x. All right, so that's awfully strange, but anyway, yeah, so if you plug in 2, let's see, what does that give you? That's going to give you f prime of f of 2 times f prime of 2, which is, okay, what is f of 2? I think we said that earlier. That's just 4, right? Times f prime of 2, we said what that was, right? F prime of 2 is 2. Okay, well now, but what's f prime of 4? That's the slope at 4, which is undefined. Which is undefined because there's a corner. Bummer. Okay, I mean, I'm assuming that's not a mistake, right? 11e should say undefined. Oh yeah, look at that. Y prime equals frowny face. What is going on with the alignment in this problem? Just what is going on? This frowny face is so far below the equal sign. Okay, anyway. Ugh, oh my god, we're almost there. I'm exhausted. I'm not gonna lie. Okay, y is equal to f of x over x squared. So the quotient rule, right? So yeah, so quotient rule says derivative of the top, which is f prime, times the bottom left alone, minus the top left alone, times the derivative of the bottom, all over the bottom squared. Well, x squared is x to the fourth. So there's our derivative. You could clean this up a bit before you go any further. You don't really need to, but you know, you can pull out a common factor of x from the numerator. So that would leave you with f prime of x times just x minus f of x times 2, right? If I just pull an x out of each of these, so one here and one here, I think that leaves me with just, yep, what I want. Okay, very good. And then, yeah, and then I can cancel this x here with one of the x's down below. I don't even know why I bothered to do this. It's not really going to save me much time in the end, but whatever. So f prime of x times x minus f of x times 2, all over x to the third. And then you just got to plug in 2, and you know, you can do that on your own. Okay, I don't think that I need to go through that. Okay, 28. I mean, you know, yeah, this could be annoying with the evaluation of the trig functions, I suppose. So AP 29, we're almost done. So we need to find the derivative. Chain rule, that's going to be f prime of x equals secant squared of blank. 2x goes on the inside, but then times the derivative of the inside function is 2. Fine, so we want to know f prime of pi over 6. So I just need to plug pi over 6 into this thing. So that's 2 times pi over 6 times 2. So that, no, this is not what I wanted. So that's going to be equal to secant squared of, I think that just becomes pi over 3 times 2. So what is this really? I mean, secant squared of something just means like secant of the thing quantity squared, right? So times 2. What is secant of pi over 3? I have no idea. I have to think about the reciprocal function. Secant of pi over 3 is just 1 over the cosine of pi over 3. Oh my god, this is going to be annoying. Times 2. All right, and then 1 over what's cosine pi over 3? That's a half. Okay, so that's actually not so bad. All squared times 2. So the 1 over 1/2 is just 2. So in fact, this is just 2 squared times 2, which is 8. Okay, good. I was a little bit afraid that that wouldn't be one of the answers. Yeah, AP number 7. Yeah, so what is this one saying? It says that if f of x is equal to this function here and g is just some differentiable function, what is the derivative of f of g of x? Well, what is this called? AP7? Okay, so AP7. So f of x is equal to x squared minus 4, and we want to know the derivative of f of g of x. Is that right? Yeah. So that literally, I guess you could just say, you know what, that's literally like f of g of x, that just means plug g into f. So like you could just replace this x with g of x. So that would be, okay, so we want to know the derivative of this function. Let me just rewrite this function first. Like what even is this function? F of g of x just means replace this x with g. So that's g of x squared minus 4. So instead of x squared minus 4, it's g of x squared minus 4. So what's the derivative of this function? Well, it's just, you know, the derivative of this guy right here. The derivative of this first term here, of course, requires the chain rule. So that's going to be 2 blank. G of x goes right here times the derivative of the inside function, which is g prime of x, and the derivative of this is 0. So there's our derivative, and I think we're done, right? So we're just looking for 2g g prime, essentially. 2g, no. 2g prime, no. 2x g prime, no. Here we go, 2g g prime. That looks right to me. It looks like it's d. And then this one here, the table above gives values of, this is AP21. The table above gives values of f prime, g, and g prime for selected values of x. If h is equal to f of g of x, what is the value of h prime of 1? Well, okay, I mean, if h is equal to, what is it, f of g? Well, that means that h prime of x can be found by using the chain rule. Outside function is f of blank, so the derivative of the outside function is f prime of blank of g of x times the derivative of the inside function, which is g prime of x. Cool, so I want to know what is h prime of 1. That's going to be f prime of g of 1 times g prime of 1. So I can probably figure all this out from the table, presumably, right? So what is g of 1? Looks like it's 3. So that's f prime of 3 times g prime of 1. What's g prime of 1? Looks like it's negative 2. So that's times negative 2. All right, and then last but not least, what is f prime of 3? F prime of 3 is 7. So that's 7 times negative 2 is negative 14. Great, looks like the answer is B. And then, oh, thank God. The function f is defined by blah, blah, blah. If g is the inverse function of f and g of 2 is equal to 0, what is the value of g prime of 2? Well, remember, I mean, I give you a hint about this. So this is AP 29. When I give you a hint about this and I tell you that, you know, what it means for two functions to be inverses is that if you compose them, you get x. Like, because what this equation is really saying is that, you know, if you start with x and then apply g and then apply f, you get back to where you started. So this is what it means for f and g to be inverses. Now the thing is, I can take the derivative of both sides of this equation. The derivative of the left-hand side using the chain rule is f prime of g of x times g prime of x equals 1. So there's the derivative. Oh boy. Of course, what is f prime of g of x? Oh, this problem's annoying. Well, I can figure out f prime, right? Because I've got a formula for f. F prime of x is going to be 3x squared plus 4, which means that f prime of x is equal to 3 times g of x quantity squared plus 4. All right. That's not what I meant. That is f prime of g of x. There we go. So there's f prime of g of x, right? And so okay, they do tell you what 2 is. Okay, great. So yeah, this problem's getting a little ridiculous, but I have this equation right here, and then I just found that f prime of g of x is this guy right here. So in fact, I can replace this, I can replace this guy right here with this guy right here, and that will give me 3 times g of x squared plus 4 times g prime of x is equal to 1. Yeah, this problem. Maybe there's a smarter way to do it, but I'm pretty exhausted. My brain's at about 1% right now. And then if I plug in 2, I should be able to solve for g prime of 2, right? Because if I plug in 2 now, I get 3 times g of 2 squared plus 4 times g prime of 2 equals 1. And so g of 2, they tell you, right? They say it's 0. So that's 3 times 0 squared. That's just 0. So this whole thing in brackets is just a 4 times g prime of 2 is equal to 1. So you find that g prime of 2 is equal to 1/4. That's a pretty tough problem. I wouldn't worry too much about it if you didn't get that. I'm not going to put something so ridiculous on the test. Okay, that's it. Oh my god. Wow, I'm really tired. It's been a rough day for me also, but doing all that talking has taken its toll. So I hope this was useful. I hope someone watches it, and see you guys all soon.